Recall from the last lecture, we were concerned with a vector y of outcomes, which is n by 1, and we had a matrix x, which was n by p. So in this lecture, we're not going to focus on x, and because I can't write out a bold 1 like I can when I was typing up the lecture notes, I'm going to write as j times j with a little n by it. We want it to be an n by 1 vector of 1s. So this is just equal to 1 up to n times repeated by 1. So imagine, for example, in our least squares discussion that we talked about last time, we have a bunch of y values. Here's y, and there's no really corresponding x values, so I'm drawing them all in one column. And I just want to find the horizontal line that best describes them in the sense of minimizing the sum of the squared distances. Okay, well in the last lecture we did that by minimizing the vector y minus, and then in this case it would just be jn times beta, which would be a scalar, squared. We wanted to minimize that. And we found that the minimizer of that would satisfy beta hat equal to jn transpose jn inverse jn transpose times y. Now, a vector of 1 transpose times our vector y, that's just the sum of the elements of y. A vector of 1's transpose times a vector of 1's is just a sum of n 1's, which is n, so the inverse of that is 1 over n. So this quantity is the average of the elements of y's, or y bar, the scalar y bar. Okay, so it is interesting to note then that if we were to take y and then subtract off jn times y bar, our best estimate of the horizontal line that best predicts the y's, if we were to take that, right, we could write that out as y minus jn times jn transpose jn inverse, all right, t for transpose, jn transpose y, okay? And then I can write that out as I minus jn transpose jn inverse jn transpose y. So this multiplication, pre-multiplication by this matrix takes every element of y and subtracts off the mean, or in other words, mean centers the vector y. And it's clear to see that this mean centers it, because what if I were to pre-multiply it by jn transpose times 1 over n? Okay, so remember that pre-multiplying any vector by that will take the average. So let's pre-multiply by jn transpose times 1 over n and see what happens to prove ourselves that we've mean centered it. So if we've mean centered it, then if we take the mean, we should get 0. Okay, so here's our mean centered version of y. And then I'm going to pre-multiply that vector by times 1 over n times jn transpose, and I'm suggesting that should give me 1. I'm suggesting that should give me 0. Okay, so jn times I here, that's just jn. And then look at this, jn times this will give me jn transpose times jn. Let me write it out. So we get jn transpose from multiplication of these two together. Then we get minus jn transpose jn times jn transpose jn inverse times jn transpose, and I'm running out of room here. And that whole thing times y. So this is just the inverse of that, so those go away. And then we have a jn transpose minus a jn transpose, which is 0. So what I hope you've seen is that pre-multiplication by I minus jn transpose jn inverse jn transpose, pre-multiplication of that vector times any vector will then mean center it. So as a specific example, if I have a matrix X, which is n by p, and I pre-multiply it by it, it will then, that's the same thing as multiplying each column vector of x by that matrix, so that mean centers the columns of x. Conversely, if I post multiply x times I minus JP transpose JP inverse JP transpose, that will mean center every row of x. And this is a very convenient operation. And we've seen that if we multiply this matrix I minus this Jn matrix, if we multiply it by Jn on the left, Jn transpose on the left, or Jn on the right, it will give us 0. The last thing I'd like is just for you to note the form of this matrix. So the I is, of course, the diagonal matrix of 1s. But Jn transpose Jn, this term part right there is 1 over n. And then the outer product, Jn, so that's just a scalar. The outer product, Jn times Jn transpose, the outer product of two vectors of 1s is just a matrix of 1s. So I might write that as J n by n, meaning a matrix of 1s. So that's the form of what that matrix looks like. It's a diagonal, diagonal matrix of 1s, and then a matrix of all 1s pre-multiplied by a 1 over n. And that's the matrix that if multiplying any vector or matrix on the left will center the columns, and multiplication on the right will center the rows.